Hey kids, how you doing? We are getting into chapter 12 now, and this is area. A lot of times when students first see that, it's area, this is going to be easy, um, they kind of let their guard down. So stay on top of things. This can be a very tricky unit. In some aspects, there's a fair amount of information coming your way. So you definitely want to be following along here. So we're going to use the same document for the next two lessons. Okay. Uh, so I'm just going to go partially through this one for what would it be? Wednesday, May 6th. And then we'll just continue on the same document on Friday for May 8th. Now, there will be two separate videos. I will stop the video halfway through, but you're going to use the same document for the whole thing. All right? Okay, let's see how this goes here. Some of this today will be pretty easy. So, first of all, I mean, really basic square and rectangle. Obviously, you guys have known the formulas for that for a long time. Rectangle, of course, is just length times width. Sometimes people say base times height. Same thing, it's fine, doesn't matter. Square, of course, is a special situation where you just square the side. Pretty simple there. I don't need to go into that, I don't think. So here, this is like a restriction problem. It says, what restrictions does this place on X? So you know that your area has to be between these things. So we know that the length times the width has to be less than 84 and greater than 124. I don't know how often you've seen inequalities like this. It's not hard to solve, but I just wanted to put it out there because sometimes you do see this. So if I distribute, and now I just want to isolate the x, but I'm going to isolate the x in the middle. So I'm going to subtract 32 from all three places, right? So I get 40x is between 92 and 52. Sorry, there should be an x there. And then, of course, you do a little division, and you will get some decimals, 1.3. X is in between 1.3 and 2.3, I believe. That's just a restriction problem there. This next one here says what? The two diagonals of a regular hexagon form a rectangle. Each side of you should do this one first yourself, okay? So maybe press pause here and go ahead and give it a try. Each side, I'll do it here in just a second. Each side of the hexagon is 12. Find the area of the rectangle to the nearest tenth. You know, honestly, let's cross out that nearest tenth. There's no reason why you can't do this in simplified form. All right. So if that's 12, that's 12. Remember, this is a regular hexagon. If you remember from your polygon unit, all the angles of a regular hexagon are 120. So if that's 90, this must be 30. And this is clearly going to be an isosceles triangle. And drop in an altitude to create two congruent 30, 60, 90 triangles. So if I got 12 as hypotenuse, this little piece here would be 6, and this would be 6 root 3. So we have a rectangle with side of 12 and another side of 12 root 3. So easy peasy there. All right, so parallelograms. We've talked about this briefly in class before we left a time or two. Remember, folks, the area of a parallelogram is just like an area of a rectangle. You can envision this triangle being cut off the edge of the parallelogram and then pasted onto the other side. And then you just create a rectangle. Now, this base is the same thing as that base. You just have to remember that the height is not this other side of the parallelogram. The height is the perpendicular distance across the figure. So area of a parallelogram is just simply base times height, just like it would be for a rectangle. Okay. Now a triangle, you guys have done this forever. Of course, a triangle, you see here, it's really like half of a parallelogram. So that's where this base times height over 2 comes from. Okay. So, most of the stuff you guys have known, so it's not really much new here. There's some basic things as to where it came from. Okay, we're going to get into a new formula here on the backside in just a moment. I would like you to try these three problems down here. Usually when I have the students do this in class, and then I give them a little bit of time, I quickly walk through. And I would say about a third, somewhere 33 to 45% of the students do not get them all right. And it's not because they don't know what they're doing. They're just a little bit careless, and you got to be careful. So please take your time and go ahead and do all three of these and check back here in just a moment. Okay, so if that's 60, this is 30. So that's 6. That's 6 root 3. Area is 1/2 the base, which is 3 root 3 times the height. So you get 18 root 3. On this one here, I know everyone's thinking, this is the base. I got to draw in this altitude, and you don't have to. Remember, a triangle has 3 different bases, 3 different heights. If this hypotenuse is 12 root 2, this is a 45, 45, 90 triangle. We know that these sides are both 12. Well, let's use them as the base and the height. So 12 times 12 divided by 2, our area is 72. No need to draw an altitude in there. Now, you're going to have to sometimes, but remember, any side of the triangle could be the base. A triangle has 3 bases, has 3 heights. Use whatever is most convenient. Okay? Equilateral, the first time you see something like this, you're going to drop in an altitude here, and that would be 6, and that would be 6 root 3. Now, remember, the whole base is 12, so half of that base is 6, and 6 times 6 root 3 is 36 root 3. So I'm guessing if you made a mistake, some of you forgot to do base times height over 2. Be careful with that. Very easy to forget. A lot of students do. And just remember that you have multiple bases and multiple heights at your disposal. Okay? All right, on the back side, you can do these top 3 problems and 2A, 2B, and 3. Try to do number 3 over on the left-hand side, and then we're going to use the right-hand side for something else in a moment. Okay? So here you can check yourself, because you go ahead and do these problems. These aren't hard. If this is, we got a 30, 60, 90 triangle here. If that's 8, that's 4. Height is 4 root 3. 15 times 4 root 3, of course, is 60 root 3, and we're all done with that one. Here, 45, 45, 90. So if the hypotenuse is 9, this would be 9 root 2 over 2, as would the height. So we just have that times 20, and that would be 90 root 2. for the area. Now, equilateral triangle with a perimeter of 45. So we're going to do this the kind of more traditional way, and then we're going to derive a formula here in just a moment to use for equilateral triangles. So the first time most people do this, like we did in the previous page, we drop in an altitude. Now it says the perimeter is 45, so that's 15, that's 60. This would be 15 over 2, and this, of course, would be 15 root 3 over 2. And then we would do the area, which is 1/2 the base times the height over 2. And, 15 times 15 is 225. And we get that for an answer. Okay. Now what we want to do is we want to derive a formula. So this is going to be a new formula that most of you probably haven't dealt with before. We're going to do the same thing, but we're going to do this in general terms. So let's say we have a side of S. And if I drop an altitude, remember, this is given an equilateral triangle, of course. So this, of course, would be S over 2, and this altitude would be S root 3 over 2. So when I want to find the area of this equilateral triangle, area would be 1/2. The whole base, of course, is S. And then the height is S root 3 over 2. So what do we get? S times S is S squared, root 3 over 4. And there is your new formula for any equilateral triangle. It is just side squared root 3 over 4. Okay. Now let's go ahead and use that for this one that we did here. Perimeter of 45, side is 15, 15 squared, 225, 225 root 3 over 4. It's really quick and painless. So that's a very handy formula. So that was a real short lesson. That is really all you need to do the first homework assignment of the week. Okay. We're going to continue with the same document with the next video, which you'll find on the Canvas homepage. So next one video is going to be a little bit longer. There's some more involved problems, and we have to get into some new different shapes as well. So we'll call it there for now for this video. All right.